Jan 2023, normal 2 hours and 40-minute exam, as we are accustomed with, dealing with, looking at question 1A, part 1, and they're asking us to round each figure in this expression below to one significant figure to give an estimation of this. Now, square root of 108 is approximately, if I do it correctly here, on the calculator, you get like 10.39, and approximated to one significant figure, that'd be like 10, and 19.72 approximated to one significant figure, because 7 is more than 5, you add 1 to the 19, it becomes 20, and 5.296, 2 is less than 5, so the 5 stays as it is. So you will get 10 over 25, which is 0.4 to one significant figure. All right, going down, part 2, you want to find the exact value of 3 and 3 is divided by 5 and 2 plus a third. All this could be done on your calculator, but for the sake of just explaining it, as you would know using BODMAS rule, you work out the brackets first. So 5 and 2 plus a third. We all know the routine. LCM is 12. 12 into 12, 1. 1 by 5 is 5. 3 into 12, 4. 4 by 1 is 4. When you add it, you get 9 over 12 for this section. Then it's this part here, which you convert improper fraction. 3 by 8 is 24. Add 3 is 27 on 8, being divided by 9 on 12, which... essentially, I did choose to reduce this 3 into 9, 3 into 12, 4. So I'm dividing 27 on 8 by 3 on 4. As you know, when you divide by a fraction, you flip and multiply. So we multiply by 4 on 3. 4 into 4, 1, 4 into 8, 2. 3 into 3, 1, 3 into 27, 9. 9 by 1 is 9. 2 by 1 is 2. And they wanted a mixed number. 2 into 9 is 4 remainder, 1 on 2. Again, this could be done on your calculator, just saying. Part B, talk about COVID-19 pandemic. Number of available seats in the hall was reduced from 125 to 93. Calculate percentage decrease. Now, percentage decrease is the actual decrease divided by original value by 100%. The actual decrease will be 125 minus 93, which is 32, divided by the initial value of 125. Multiply by 100%, calculator get 25.6% exact. Okay, cool. Part C, might invest a certain amount of money in a bank that pays compound interest at a rate of 2.5% per annum. At the end of 2 years, the value of our investment was $7,564.50. Calculate the amount Micah invests. Using the compound interest formula, let's see what's going on here. So we know that the amount of the investment was this value. So you have the 7,564.5 equal to P, which we do not know. That's the amount that Micah would have invested initially. Open bracket 1 plus R. R is 2.5 over 100 to the power 2 because it's 2 years. This part will get you 1.050625 by P. Will give us our value here. And making P the subject, you just divide the 7,564.5 by a 1.050625 to give you $7,200. That's how much Micah invested. So question 1 was finished there. Going into question 2, going into some algebra, simplify x cubed to the power 2. When a power raised to another power, you multiply the 2 powers. 3 2s are 6, so you get x to the power 6. Y to the power a divided by y to the power minus 5. When we divide, we subtract powers. So it'll be 8 minus 5. So minus 5 minus a plus, and 8 add 5 will give you 13. Y to the power 13. Part B, part 1A, xy minus y squared. They want us to factorize. We pull out what common, which is y. Remain with what x, and y into y squared is y. So this is the answer here. Y open bracket x minus y. Part B, x squared minus y squared. This is what we call difference of two squares. And one way of factorizing a case like this, when you have difference of two squares, you have your two sets of brackets, right? Double brackets, and in one case, you find the square root of x squared, which is x. So you have x in both sets of brackets. Then you find the square root of y squared, which is y. And you put y in both sets of brackets. In one case, you put minus, and the other, you put plus. If you have put the plus first and then the minus after, it really don't matter. This is the answer for this. They say hence simplify this expression. Now, when you say hence again, it means that you're using from before. So the xy minus y squared, we got that to be y into x minus y. And the x squared minus y squared, we got this below. So when we divide and you cancel out the x minus y, top and bottom, and you can remain with what? Y over x plus y. Simple. Part C, we have two rectangles, M and N. And you can see the dimensions for M and for N. And they're saying here, given the difference between the areas of the two triangles is 64 cm squared, show that x squared minus 2x minus 35 is 0. What we're going to do is find the area of M, which you know is length by breadth. So it'll be x minus 3 by 3x plus 4. X by 3x is 3x squared. X by 4 is 4x. Minus 3 by 3x is minus 9x. Minus 3 by 4 is minus 12. This will give you 3x squared. 4 minus 9 is minus 5x. Minus 12, that's the area of M. And then let's find the area of N. Again, length by breadth. It'll be x minus 3 by x plus 2. And x by x is x squared. X by 2 is 2x. Minus 3 by x is minus 3x. Minus 3 by 2 is minus 6. This will give me x squared minus x, because 2 minus 3 is minus 1, or minus x, minus 6. Now the difference in the areas, it says 64. So what we are doing is that the area of M subtract the area of N will give me 64. So you have 3x squared minus 5x minus 12, subtract x squared minus x minus 6 in brackets equals 64. What will that give us? You bring down the 3x squared minus 5x minus 12. But then you have minus x squared. And then minus 1 minus is a plus, so it's plus x. And minus 1 minus here is plus, so you have plus 6. Equals 64. 3x squared minus x squared is 2x squared. And minus 5x add x is minus 4x. Minus 12 add 6 is minus 6. And that's equal to 64. So you have 2x squared minus 4x. And they carry 64 across. You have minus 6 minus 64 to get you minus 70 equal to 0. Now in a case like this, x squared minus 2x minus 35 is 0. How did I get that? We divide each term by 2, and this is what we will get, which is what he asked for. So I know it would have been a little lengthy, but just once you pay attention to each step, you should be able to get it, right? So this was question 2. Question 3 is a little bit tricky. This deals with transformations. And, they're showing 3 quadrilaterals, P, Q, and R. P, Q, and R in a square grid. It's Q and R are the images of P after it underwent 2 different transformations. So I guess P was used to form Q and R. Okay. Going below, the same on the grid, draw the image of quadrilateral P after a translation by the vector 10 minus 4. Label this image P prime. Okay, so what I did is that I took a coordinate from P, which I took this one, minus 8 and 6. Okay, that's this corner of P. And then see what I did? I add 10 and minus 4. So minus 8 add 10 is 2. 6 add minus 4 be 6 minus 4 is 2. And I plotted that point. You can see here 2 with 2. That's this here. And then I use minus 6 and 6 from P, which is this corner. minus 6 with 6. And I added the 10 and minus 4. So minus 6 add 10 is 4. And 6 minus 4 is 2. And I plotted 4, 2. You can see there, 4 with 2. So once I plotted these 2 points, watching the dimensions, I just completed the rest. I didn't find for each point a P and work it out. I just found for 2 points, the 2 extreme ends, and I know where the peak is and where the bottom would be, which is 2 blocks below, and the peak is 1 block above these 2 points. And I got P prime. Remember in exam, we're trying to save time. So there's any way that any technique you could use it. Produce a reflection in the line y equals 0. Label this image P double prime. Now y equals 0 is your x-axis. And if I reflecting P about the x-axis, remember your reflection would have the same size, but it would just be equidistant from the axis of reflection. So you see how this bottom point is what? 4 blocks from the x-axis. So it's just 4 blocks below. 1, 2, 3, 4. You have this point. And we all know this point is what? 3 blocks from here. So you just have 3 blocks down, and it just could connect the rest, because these points are just 1 square on either side, and we could connect to get P double prime. Quick and easy. Part B, describe fully a single transformation and maps quadrilateral P onto Q. Okay. Well, what I did is that I extrapolate lines. As you can see, running from point to similar point, point to similar point, point to similar point, point to similar point. And when I extrapolated them, they all converge at the coordinates minus 10, 7. So this is my point of enlargement. Okay, my center point of enlargement, where you could see that P was enlarging to form Q. And if you check it correctly, 1, 2, 3, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see there's an increase of 3 times. Okay, you see the magnification factor is 3, and center point of enlargement minus 10, 7. Now, area of Q is 9 times more. I just went a little more in detail to talk about that, because normally the magnification factor, you generally square it to get an idea of the increase in area. That's extra if you want to put that in to make sure you solidify your answer. I choose to give that. So if the magnification factor is 3 times, the area will be 9 times. 3 squared is 9. So you normally square the magnification factor to get the increase in area. To get quadrilateral R from P, this was a rotation, and you could see it was rotating 90 degrees in an anti-clockwise fashion to form Q. So I rotated P 90 degrees to get R, and I had to rotate it what? Anti-clockwise. That's this way. Okay, and it's about a point of rotation. And what's really interesting is that to try and find the point of rotation. Yeah. So the point of rotation, most people might pick the origin for that, and I will definitely confirm that position of rotation in a bit to you all. Okay, but in the meantime, we do know it was rotated 90 degrees anti-clockwise. Okay, that for sure. Very interesting and tricky question. Question 4, lines L and M are drawn on a square grid. Write down the coordinates of the x-intercept. So the x-intercept of L is where it cuts the x-axis, that'll be what, 6, 0? That's here. Okay. Well, y-intercept of line M, that's where the line cuts the y-axis, that's what? 0 minus 2, that's here. All right, 0 minus 2. And I could make these pointers just a little neater. Okay. Part B, the equation line L, which is x plus 2y minus 6 equals 0. Find the value of k given that the point 9 comma k lies on line L. Okay. Now, interesting is that the x value is 9. You substitute that in there, while the y value is k. So you will realize 9 add 2 by k minus 6 is 0. Okay, with substitution. All right, and from this you will realize that what? 9 minus 6 is 3. 3 add 2k is 0. Carry the 3 across, you get minus 3. Then you divide by 2, you get minus 3 on 2 is k. Find the equation of line M in the form y equal mx plus c. All right. Well, line M is this one. So what we need to do first is get the gradient of M. So gradient of M, x1, y1. I picked it as 1, 0, that's here. And then my x2, y2, I selected 3, 4, which is here. So these are your 2 points. So gradient y2 minus y1 over x2 minus x1 will be what? It'll be 4 minus what? 0 divided by what? 3 minus 1. So you get 4 over 2, which is 2. And since y equal mx plus c, we know y equal to what? 2x, the 2 from here. Okay, that's this 2 here. Sorry, that meant to be arrow. That's 2x. And c is what? C is your y-intercept, which we did get as what? Minus 2, right? We answered this earlier. So it'll just be 2x minus 2. D, this is show by calculation that the line L and line M are perpendicular. Gradient of line L, I'll show you what we did. If I, going back to this, I make y the subject of the formula, you get 2y equal what? Minus x. What? And that minus 6 become what? Plus 6. And then you divide by 2 below. For each one, you get what? Minus x on 2 plus what? 6 divided by 2, 3. Now, the value in front of x is the gradient, which is minus a half. So you know the gradient of L, because L we're dealing with here, is minus a half, while the gradient of M was what? 2. Okay? Now, in a case like this, you can see if you multiply both gradients, you get minus 1, suggesting that L and M are perpendicular. You say line L and line M represent a graph of pair simultaneous equations. Using the graph, write down the solution of pair simultaneous equations. Solution will be where both lines intersect. And you will see where they intersect at what? 2 and 2, okay? You can see that there, 2 and 2. And that's your solution, right? X is 2, y is 2. Question 5. Cumulative frequency curve shows the information about time taken by 200 students solve a math Olympiad problem. Okay. Regular O-give curve. Using the cumulative frequency curve shown below, find an estimate for the number of students who took more than 50 minutes to solve the problem. All right, so 50 minutes, you know, we can see number of students is 4. How did I get that? If you go up with 50, go up and go across, you get 196. Now, the reason how I get that is because each block is 4, because 200 minus 180 is 20, divided by 5 blocks to get you 4. So when you reach 50, you'll get 196, which will be the amount of marks, right, for 50 students or less. So I will repeat that, sorry. 196 is the number of students who took 50 minutes or less. If you take more than 50 minutes, you have to subtract the 196 from 200, and you will get 4 students who took more than 50 minutes. Median time. Okay, median time will be what? You look for half of 200 is 100, go across, come down. Okay, you get like, I get like between 33 and 34. I get like 33.5. You know, that's what I got. Okay, 33.5 minutes. Cool. Probably that a student chosen at random took at most 28 minutes to solve the problem. Okay, 28 minutes. So 28 minutes, you know, each block is 1. You look for 28. That's 2 blocks on 30 and go across. You will get 64. So probability of 20 minutes or less will be 64 students over total 200. Divide by 4, you get 8 over 25. Okay. Part B, part 1, using cumulative frequency curve, complete the table. All right, 15.5 is the midpoint. That's for the interval 11 to 20. You want the frequency. Normally, when you're reading frequencies for intervals, you use the upper limit. Okay, so your upper limit is 20. So I look for 20. Go up, go across. Okay, so 20 is found between, if I look carefully, yeah, it's between 32 and 36. So you get like what, 34? I'm getting 34, between 32 and 36, okay? So I get 34. And the thing is that 34 will represent for 20 and less. Now, remember, they want for 11 to 20. So if you have 12 people, it was 1 to 10, and 34 was 1 to 20, essentially. You subtract 12 from 34 and you get 22. Some students may make the error putting 34, but that's incorrect. You have to subtract 12 from it and you get 22. Frequency by midpoint, it will just be what? You're multiplying a 22 by 15.5. And if I do that over my calculator just to make sure, 22 by 15.5, I get 341. I mean, I could show it, but you might not see it, you know. It's kind of cutting across anyway on my vid. So that's that. Going down to here with 45.5. One simple way of doing this is I add everything else and subtract it from 196. Okay. And I get 36. I'm adding 12, 22, 42, 84. All right, so I could add all of this, subtract it from 196, because 4 less than 200 is 196 anyway. So I add all of this, 12 add 22 add 42 add 84, subtract it from 196 and I get 36. Okay, again, I will say how I get 196. 200 minus 4 is 196. And you subtract the rest and you get 36 here. Multiply 45.5 by 36, it should get 1638. And let me just confirm that quickly before I move on. Yep, correct. 1638. Part 2, using the information, calculate and estimate the average time. As you will know, mean is your sigma fx over sigma f. I couldn't get the sigma symbol, but you know, sum of fx values over sum of f. If I add all of this coming down, I should get 6320, and I divide by my sigma, which we all know is 200, and I get 31.6 as your average time. That is in minutes, and maybe I should put in minutes. Yeah, it's minutes, right? Cool. So that question took a little time, but we got through, right? Number 6. Diagram below shows a scale drawing of a running track. So it has a rectangle, 2 semicircles, right? You got Ln and MP. Ln equal to MP, which is 49 meters. Ln equal to MP, which is 98 now. So Lm is NP, which is 98. They say show that the total length of the running track is 350. What I did is I combined the 2 semicircles to get a whole circle. So you know the distance around a whole circle circumference, that's pi by diameter. That's 22 and 7, which is your pi, as seen here. By a diameter, which is 49, you get 154 meters squared. And that should not be squared, that should just be meters. Do apologize for that. All right, that's just meters because circumference, not area, right? And what we do, we add that 154 to the 98 top and bottom. Okay, because remember you're running around the track. So 98, add 98, add the 154, which is the distance around the 2 semicircles to get 350 meters. The Newton walks at a constant at 1.4 meters per second. Calculate the time it will take him to walk 7 laps around the track. Well, we know time is distance over speed. That's assuming speed is constant, which it is. And what will be your distance? It will be 350 by 7, because 7 laps, divided by 1.4, get 1,750 seconds. Part B, Tafari runs 1 lap of the track in 68 seconds. Determine number of laps Tafari can complete in 1 hour, running at the same speed. Well, you know, in 1 hour, you have 3,600 seconds, you know. 60 by 60 will get 3,600. You know, 60 minutes in an hour, and each minute is 60 seconds. So it's 60 by 60, 3,600. Divide by 68, you get 52.94. which is approximately 53 laps, right? Nice whole number. They say Nathan completes 1 lap or running one of the track every 72 seconds. Tafari and Nathan started running at the same time, and they started from point L. Okay, that's here. Each completed a number of laps on the track. Calculate the least number of laps that each will complete before they are both at point L again. Well, what we simply need to do is find LCM, right? You find the LCM of the 72 for Nathan and the 68 for Tafari. You get 1224 seconds. Keep on trying figures until both could go into it. You know, if I multiply 72 by 68, you get 4896, and you just sort of cut down from there. That's the only trick with this. Another trick is you use the larger number, 72, and keep on going multiples of that. You may have to move a little fast there, but you know the answer is 1224, and you divide 1224 by 68 for Tafari to get the number that's 18, while you divide 1224 by 72 for Nathan to get 17 laps. 18 for Tafari, 17 for Nathan. Number 7, go done with 6. Grid below shows 3 figures in a sequence. Each figure is made using a set of small squares of unit length that are both colored and I guess white. So you can see it. Simple enough pattern. So, you have 3 diagonal, 4 diagonal, then 5. So, and they start with 3 on top, 4, then 5. So, what do you think the fourth figure will be? 6 and then 6 across, right? Just add in 1. 1 diagonally extra and 1 across extra. So this is a table that give a lot of students trouble. We all know with these pattern finding questions, the tables can give students some issues. We're going to take our time here. Yeah, figure number, that's F. Number colored squares, C. Perimeter of figure, P. Total number of squares, T. Okay. And you could see there is a pattern. What I realized with the figure number is that you multiply by 2 and then you add 3. Like 3 by 2 is 6, 6 add 3 is 9. Or if I multiply 2 by 3 is, multiply by 2, 2 by 2 is 4, add 3 is 7, 1 by 2 is 2, add 3 is 5. So 11, you're multiplying by 2, which is 22, and you add 3 to get 25. That is the pattern. With this here, we are seeing that you're adding the figure number to 2 and you're squaring it. So 11, you're adding 2 and you're squaring it. So in 11 plus 2 is 13. 13 squared is 169. But here we want to go backwards. So what are we doing here? We multiply by 2 and add 3. We're going to go backwards. We first subtract 3 and then divide by 2 afterwards. So 49 minus 3, 46. 46 over 2 is 23. With this side, you multiply 49 by 2, add 2 and you get 100. How did I get this? Okay, if you look at what's going on, the pattern between the number of colored squares and perimeter, if I multiply 5 by 2 and add 2, I get 12, right? 5 2s are 10, 10 add 2 is 12. 7 by 2 is 14, 14 add 2 is 16. 9 by 2 is 18, 18 add 2 is 20. And that's what we get. So it's same with here, 49 by 2, which will be 98, add 2 is 100. So what are your formulae for this? We know you're multiplying n by 2, like with this, and you add 3, that's 2n plus 3. With this one, what I just observe off the bat, there are other ways to do it, right? But what I observe off the bat, I just multiply this by 2, and I add 2 and keeping with this. So 2n plus 3 by 2 and I add 2. That's one way of doing it. Okay, so 2n by 2 is 4n. 3 2s are 6. And then you add the 2, you get what? 4n add 8. Alright, 4n add 8. This plus 8, it's there though, and it's not coming out too clear. With this side, you realize is what? And add 2 all squared, right? We learned that. We observe it from here. And what's n plus 2 all squared? It's n plus 2 by n plus 2. N by n is n squared. N by 2 is 2n. 2 by n is 2n. And 2 by 2 is 4. Okay? So maybe I can make this a little better. Alright. We will get n squared add 4n add 4. Now, so how many white squares are in figure 11? Sorry, they're just getting caught up with the plus 8 there, but it's 11. How much white squares? So with 11, we know that the number of color squares is 25, and the total number of squares is 169. So the number of white squares will be what? 169 subtract 25. Because it's only 2 colors, it's white and colored, right? So it's 169 minus 25, you get 144. So question was a little tricky, I think, coming near the end. And this is where with practice we get better, right? Get better at seeing these things. 2, with question 8 is functional relation. So f of x is 4x minus 1, g of x, x squared minus 5. H of x is 3 to the power x. Find g of x minus 2 in its simplest form. So g of x minus 2, you're swapping x with x minus 2. So it's x minus 2 squared minus 5, which is x minus 2 by x minus 2 minus 5. And that will be what? X by x is x squared. X by minus 2 is minus 2x. Minus 2 by x is minus 2x. Minus 2 by minus 2 is plus 4 minus 5. Now give me x squared minus 4x minus 1. The one f inverse of 11, well, first thing you need to do, students, is find the f inverse of x. We gotta get the inverse function first. So you know f of x is 4x minus 1. How do we get the inverse? First step I always teach students, let f of x be y. So you have y equal 4x minus 1. Then you switch the positions of x and y. So we have x, hey, you make it y prime, because y prime will be the inverse of y. And where you have y, you make it x. So what are you going to get? You're going to get x equal what? 4y prime minus 1. And then you make y prime the subject of the formula. That'll be what? X plus 1. And then you divide by 4 below and you get y prime. So f inverse of 11 will be what? I'll just replace an x with 11. So it'll be 11 add 1, which is 12. 12 over 4 is 3. Going down, we want to find the value of each of 1. And that is an example of a composite function, right? You want to get each of 1. There are many ways to do this. Again, what I had choose to do is actually get each of x and then find each of 1. You can do other ways, right? There are other ways, but I choose to do this because I'm kind of teaching it too. So, you know, we start from right and go to left. So you have each of 1, but let's assume it's each of x for now. I'm going to let each of x be big X. So what will I get? I'll get each, which is an extreme left now, each of big X, which is what? Each of big X will be 3 to the power of big X. And then I'm going to replace big X back with each of x. So it'll be 3 to the power, what? I'm replacing big X with what? 3 to the power x. And then each of 1, I'm just replacing the x with 1. So it's 3 to the power of 3 to the power 1. We know 3 to the power 1 is 3. So it comes down to 3 to the power 3, which is 27. Part C, function f, you know, f of x is x squared minus x minus 2. Welcome to the table below and plot the graph for this function on the grid. So, okay, well, let's first figure out the values. Minus 2, what will be f of minus 2? Following this, what will be minus 2 squared minus 2, subtract 2. That will give me what? Minus 2 squared is 4. Minus 1 minus is a plus, so it's 4 plus 2 minus 2, which will give me 4. So I put 4 there. With 0, it'll be what? 0 squared minus 0 minus 2 will give you back minus 2. And we plot the points. So, you know, minus 2 with 4. I try my best here. Following with the scales they give with 2 cm to represent 1 unit on both axes. So 2 with minus 4, no, minus 2 with 4 is here. Minus 1 with 0, that's this. 0 with minus 2, that's here. 1 with minus 2, it's here. 2 with 0. 3 with 4. And I think I got that curve fairly well, you know. And in drawing it, you had to kind of go through the minimum point where you kind of average it by symmetry, if you know what I mean, when you're drawing it. Okay. I did show some calculation to get the minimum point. You don't have to do it. You can kind of average it. But that's there for the perusal, yeah. So question 9. WX and U are point circumference. I think we could see that. TV is a tangent. Yeah, it's this. At U. UW is diameter. We're going through the center of the circle. And WXU is isosceles. So you can see with this, WXU is isosceles. 2 strokes mean equal. Using probability and state 3 reasons that explain why the angle or measure of angle Z is 45. So I'm going to show how this is 45. There are many ways to this thing. Again, I'm going to make this a little neater. So one reason is this, okay? And I'm going to go through it quickly. Angle at point X, that's this, is 90. Now, how do you know that? That's Thales' theorem, where any angle located at the circumference subtending from the diameter, which is this, that angle is always 90. And given that this is 90, right, and the triangle is isosceles, what do we know? We know that what? Y at Y, I'm calling this Y here, this angle here, and they both will be equal because isosceles. Y at 90, we get your 180 degrees. So 2y is 90 because 180 minus 90 is 90. Our y will be 90 over 2 is 45 degrees. Mind you, I put in a fourth reason. I just gave a lot. So I proved that y is 45, which is, if this is 45, z will be 45 as well, because any angle between diameter and tangent is always 90 degrees. Okay, I'm just saying that. I don't know if I could kind of get at there a little bit. Yeah. So if y is 45 and any angle between diameter and tangent at that point is 90, 90 minus 45 give you back 45, which is z. So z is 45. All right. Another reason which I just decided to give is the alternate segment theorem, which is any angle here between a side of the triangle and the tangent is equal to the opposite interior angle, which is y. So z is actually equal to y, right? 45. So I want a little extra for you guys on that. B, you can see diagram below shows a circle. Diameter what? KF. EFG is tangent to the circle at F. Points F, H, K, and J line is circumference. Okay. All right. So you want to calculate X, long story short, and you have to give a reason, right? Of course. You want to calculate X. Now, any angle that is circumference, or any angles that is circumference subtended from the same chord, which is FH, they will be equal. So X is equal to 56 degrees. Y, okay. Well, Y is not at the center because you can see the center point. So I said is the exterior angle theorem. The exterior angle of the triangle is equal to sum of the two opposite interior angles. So this Y is equal to the sum of the two opposite interior, which is X and 19. So X plus 19 is equal to Y. And we know X is 56 from here. So if I could draw around, put it there, you know, so 56 and 19 is 75 degrees. Yeah. But when you think you're done, you're still going with number 9, part C. A bearings question. We all know how this could be. Diagram below show 4 points PQR and S on level ground. So I guess it's a plan view where pillars are or will be marked or placed to mark, the outline for foundation. So these are your pillars. There's a vertical post RT at R, and from Q, the angle elevation of the top of post T is 21 degrees. Okay, find the height of the post. So took the liberty of drawing a post there, not the straightest, but you know, that's TR, angle 21 degrees, so it's off the ground. Trying to get a 3D effect is a little difficult. That's the angle elevation of T in respect to Q. So you want to find the height, you want to find TR. Now this will be 90 degrees to the base. So what do we have? We can say tan 21 is what? It'll be TR over 153. And RT or TR will be what? 153 by tan 21, you get 58.73 meters, 2 decimal place. Given that the length QS is 135, let's say calculate perimeter of the foundation PQRS. Okay, so QS is 135, that's here. This is 135. We want the perimeter. So you know we have this side, we have this side, we have this one. We need to get PS. So what we decided to use is cosine rule, where PS squared will be 83 squared at 135 squared minus 2 by 83 by 135 cos 29, which is exactly what I have here. 83 squared plus 135 squared minus 2 by 83 by 135 cos 29. 6,889 plus 18,225 minus this. You get 5,513.77. And then square root of this gets 74.25. And knowing that we could get the perimeter now, it's just PS add the other sides that we have from before, which is your 110, 153, and your 83. And you get 420.25 meters, right? 2 decimal places. So we're done with 9, and finally we're going on to our last question tonight. And what is that? Matrices, vectors, 3 matrices, Q, R, and S. Explain why the matrix product QS is not possible. Well, the order of Q is a 2 by 2, right? 2 rows by 2 columns. Order of S is what? 3 by 2. So immediately you can see the number of columns of Q doesn't match the number of rows of S. And once they don't match, you can't multiply. Number of columns of the first matrix must match the number of rows of the second matrix. So they can't multiply them. Still the order matrix SR. Well, the order of S is 3 by 2. And the order of R is what? 2 by 2. Cross out the 2's remaining at 3 by 2. Calculate the matrix product QR. All right. So that's Q by R. And what we know is what? We know is what? First row by column, that'll be what? 2 by 1. Add minus 1 by minus 5. That's this. And then we have what? First row by second column. That's 2 by 6. Add minus 1 by 4. That's here. 2 by 6. Add minus 1 by 4. Then what we have? Bottom row by first column. 4 by 1. Add 3 by minus 5. 4 by 1. Add 3 by minus 5. Then we have bottom row by second column. That's 4 by 6. Add 3 by 4. This will give me 2, add 5, that's 7. This will be 12 minus 4 is 8. This will be 4 minus 15 minus 11. 24 add 12, 36. QR. Simple. So given A is 4 minus 1 minus 7, x, determine the value of x if the determinant, that's determinant A is 5, We all know determinant is AD minus BC, and that'll be what? 4 by x minus 1 by minus 7, which will give me 4x minus 7. Okay, A by D minus B by C. Yeah. It says equal to what? 5. Carry my sacra become plus 7. You get 4 is equal to 12. And then you divide by 4, you get 3. Done with our matrix question. We're getting some vectors here. As you can see, we are on our way out of this paper. In the diagram below, OPQ is a triangle, ARB and AOQ are straight lines. B is the midpoint of PQ, all right. R is the midpoint of AB, okay. OR to RP is 1 to 3. 1 part to 3 parts. OP is 4A. And OQ is 8B. See, 4A, 8B. So you want to find PQ. Now, PQ, with all of this information, you just look at the diagram. PQ come like what? PO add OQ. You can see it here. And PO is minus OP, which would be what? Minus 4A add OQ, which is what? 8B. PR. Now PR, which is just the switch of this, would be what? 3 out of 4 parts of PO. Yeah. Remember PR going this way. And that's 3 out of 4 parts in all of what? PO. Okay. So it's 3/4 of PO. That's 3/4 by what PO is? Minus OP, which is minus 4A. And you get minus 3. Final part on this paper. RB is RP add PB. And you're looking at RB, which is here, will be RP add PB. Yeah. And what is RP? RP plus PB. RP is what? Minus PR. You must be wondering, oh, so why are you doing that? Well, you have to look at what you have, right? You have to look at what we have. So RP is minus PR because we have PR already, which is minus 3A. So that's where we could use that. So RP is minus PR, which is minus of minus 3A. Add PB. What is PB? PB is half of PQ, which is half of this, minus 4A add 8B. So this will give me 3A. Half of minus 4A is minus 2A. Half of 8B is 4B. 3A minus 2A is A, and you have your 4B. So we were able to complete this paper